Here we have another higher order implicit differentiation example problem, and we want to find y double prime of 2x cubed plus y squared, which is going to be equal to 1 minus 4y. So the first step in solving this is we want to take the derivative with respect to x of all four of these terms. And what we're going to focus on is these y terms. So we know that these y terms are really just functions of x, and so when we take their derivatives, we're going to have this y prime term here. After taking the derivative of all four of these different terms, we can go ahead and factor out our y prime term and solve to determine the first derivative of our example problem, or our y prime term. The next step is we can take the derivative of y prime to get y double prime, which will mean that we'll need to take the derivative of our y prime term, negative 3x squared over 2 plus y. In order to take this derivative, we'll need to use the quotient rule, so we'll go ahead and process the quotient rule and take their respective derivatives. After that, we're left with this term for our y double prime, and the key here is the denominator. So we want to simplify this as best we can. And so what we're going to do is we're going to move this denominator up into the top of our fraction. And so that way we can combine like terms as you see here, and it makes our simplification process a little bit easier. So these two terms will get combined to be the negative 1 power. We're going to keep this negative 2 over here. And then the last step is we want to back substitute our y prime term, which we derived earlier. And so we'll input our y prime term of negative 3x squared over 2 plus y. And like I said earlier, we want to combine like terms. So this is really going to be 2 plus y to the negative 1 power. And so we can combine that with the 2 plus y to the negative second power to get our 2 plus y to the negative third. And then the rest is just basic simplification. And what we're left with is our solution, which is y double prime, or the second derivative.